Good afternoon, everyone. In today's lesson, we're going to kind of finish up talking about solving equations, and we're going to start moving into inequalities. And specifically, we're going to use technology to have a look at this. So we're going to be using Desmos, okay, and we might be looking at Wolfram Alpha a tiny bit, if you've ever heard of that before. So right now, either on your own device, if you've got it with you, you can bring up Desmos, or if you don't have your own device, feel free to grab an iPad from the iPad cart, and please get that ready to go. Okay, but for first example, we're going to look at how to solve this equation here, x cubed minus 3x equals -1. Okay. So our first step, okay, is going to be just rearranging that equation, right, and getting it all on the same side. So we'll bring the -1 across. So I can rewrite my equation as x cubed minus 3x is equal to, pardon me, plus 1 is equal to 0. So now we'd want to try to apply any of those factoring techniques and see if we can factor this, right? So again, first thing would be, does it have any common factors? No, it doesn't have any common factors. Could you factor this by grouping? Well, there's only 3 terms, so probably not. Is this advanced trinomial factoring? Okay, right, it almost looks like a trinomial, but I have a cubed and the x is power 1. Okay, so it's not double, and so that doesn't work either. Okay, so now we'd be at our rational zeros test. Okay, what kind of things can we try here? Well, I've actually got some pretty nice numbers, right? For p, well, there's only 1, right? 1 is the only factor of 1. Same thing for q, right? The coefficient of x cubed is 1, so my only possible number I can check is 1. So really the only things I can check in this equation are positive 1 and negative 1. Okay, so when I try that out, if I put 1 in the equation, so let's go to f of x for now, right? F of 1, okay, that's going to equal -1. Okay, and for f of -1, it's equals 3, I think. Okay, so neither of those work, those aren't roots. Okay, so we've exhausted all the factoring techniques, right? What can we do now? If you have looked at that part of the assignment, you may have had a peek at cubic formula. Okay, that is a possible way to solve this. It is kind of a bit messier than quadratic formula. Okay, so at this point, we'll switch over to technology. Okay. So we're going to put this into Desmos. We're not going to put that in verbatim, right? We're just going to graph it like a function, right? Y equals x cubed minus 3x plus 1. And we'll see where it's equal to 0. Y equals x cubed minus 3x plus 1. Okay, so there's our graph. And I can just tap on the zeros, and we're pretty much done. So my zeros are approximately -1.9, 0.3, and 1.5. And maybe there's a few more decimal places, which is nice. Okay, so that's a quick way to get your answers. Okay. Another nice online tool that can do the same thing is a website called Wolfram Alpha. Okay, Wolfram Alpha is a tool. You can type in all kinds of things into it, but it is pretty good at mathematics. Okay, so I can actually put the equation in verbatim this time. X cubed minus 3x plus 1 equals 0. Okay, and we just take equals to see what it is. Okay, so there's the same graph. If we scroll down a bit, here are 3 roots. Okay, -1.9 roughly, 0.3, 1.5. Okay, so those are 2 nice tech tools that you can use to get roots. So what I would like you to do for the next 10 minutes or so is on page 111, number 9. Just a question with, I think it's got about 6 polynomials in it, polynomial equations, and just use technology, solve. Okay, and now work with your neighbor, check that you're getting the same thing. But I'd like you to do that for about 10 minutes now, please. Okay, so again, just pause the video here and bring it back in about 10 minutes. Okay, so we're back and we're ready to go on to the next thing. So just to refer to the graph we just made, yesterday we reviewed checking for intervals where this is positive or negative. So for example, I might say this is positive between negative 1.879 and 0.347, right? And from 1.532 onwards towards infinity, the graph is always positive in those sections. Okay, so basically, to solve the inequality, solve an inequality, that's really all we'd have to do, because there's either going to be, is it above zero, below zero, something like that, okay, if we rearrange the equation. So this is going to be example 2. Here's an inequality, and we're going to solve it. So a couple ways we could do this. One, we could kind of put it into decimals right now, the way it is. Okay, and just keeping in mind we have to write them like they're functions. Okay, so I'm going to switch over for a second. So the left-hand side of my equation was x cubed plus 5. So y equals x cubed plus 5. Okay, the right-hand side of my equation is x squared plus x. Okay, now the question was, one was my first one, the purple one, right, greater than the other one. Okay, so I'm looking to see if there's any other roots here. Doesn't look like there is. Okay, so the point where they cross each other is right there at negative 1.594. So my first curve is above the second curve when it looks like that. So that's the solution. Okay, is that basically when x is greater than that number? That's when it's greater, pardon me, that's when the purple curve is greater than the other one. Okay, and that would become my solution. So I could pretty much immediately go to, this is true when x is greater than or equal to negative 1.594. Okay, and that's pretty much done. Okay, the other way we could do this is, again, just with what we were doing before, I could bring everything to the same side of the equation. So I would have x cubed and the x squared over minus x squared, bring the x over plus x, pardon me, that's minus x. Okay, plus 5 is greater than or equal to 0, and just graph it all in one equation and see where it's greater than 0. Okay, so minus x squared minus x. Okay, so there's my curve. And hey, there's the same point right at 0. So last little thing here. Okay, we'll write this using interval notation. I remember to put the greater than less than there, but you really should be writing this in interval notation. So again, when is that greater than 0? Okay, this was greater than 0 from negative 1.594 onwards. So x is in the interval of negative 1.594 off to infinity. Okay, so this is an example where I would use a square bracket because it's got less than or equal to. So I actually have to include the roots this time, including 0. Okay, so that's pretty much it. As a quick side note, I'm sure if you've printed the online notes, I'm pretty sure I made a small error here in what I had originally intended. So I'm just going to see what happens. Okay, yeah, that was what I was hoping to have, that 5 in there. But same idea, right? There's all the roots, okay, with that little tweak. So now my solution set would just look a little bit different. Okay, so for example, it is positive between negative 2.236 and 1, and then again from 2.236 onwards to infinity. Okay, but again, we just use technology, got our graph, and then use that information into the question. Okay. So that's it for today's note. Okay, the practice work for this is on page 130. Okay, and again, this will encourage you to use technology to answer the questions. Okay, just as a side note, right, tomorrow we're going to cover how to do it algebraically. Okay, so if it does factor nicely, how can we solve that inequality? So for the purposes of your assignment, right, if the thing is factorable, that's the way I want you to solve it, by doing the factors, not just going to technology. Right? That can't just be your answer there. However, again, it's a tool, right? You can certainly use it to verify what you're doing and make sure you're on the right track when you're solving some of those things. Okay, so thanks for watching, and I will see you tomorrow.